Guys, in this video we are going to see an example of inverting op amplifier. In this particular problem we are going to see how to calculate this Vout voltage. Okay, and before we approach this problem we have to know two things. The voltage across the inverting terminal is approximately equal to voltage across the non-inverting terminal. So if we assume that the voltage across the non-inverting, that is V positive, that's going to be 0 because this is connected to the ground, so this is going to be 0. If V positive is equal to 0, then V negative also going to be 0. If V negative is 0, then this VA is going to be 0. That's the first assumption. And also we have to know that current entering or exiting through this positive negative terminal is always going to be 0. And if we apply KCL at this V minus, okay, let's apply KCL at V minus. Since this current is 0, the current entering this one is 0, then the II must be equal to IF. Because this is 0, all the current entering should be equal to exiting. Therefore, II is going to be equal to IF. So we are going to have II that is equal to IF. And we can write II as VA minus VI divided by RI. Because this voltage is VA and this voltage is VI. So VA minus VI divided by the resistor in between, that is equal to II. Okay, and the next one is IF. IF can be written as V sigma, that is output voltage, V sigma minus the voltage right here, that is VA, divided by the resistor in between, that is RF. Okay, and already we found out that VA is equal to 0, so we can eliminate all the VA, right? This is going to be just 0, so we are going to have negative VI over RI, that is equal to V sigma divided by RF. Our purpose is to find V sigma, that's the output voltage. So V sigma is going to be equal to negative VI is equal negative VI times RF over RI, and that's going to be the general formula for the output voltage for an inverting op amplifier. And that's how we do this kind of problems. I hope this helps. Thanks for watching.